What's poppin', dogs? Mr. Allen here with some evaluating of logarithmic expressions in this video. And these aren't your basic evaluations, all right? We got some challenging ones here, a lot going on. So let's dive into it. We have ourselves 3 to the log base 3 of 7 minus 5 times log of 100. No base. Interesting. What's that mean? It's log base 10 of 100, right? No base implies log base 10. Plus log base 4 of 1 over 16. Now, individually, these aren't all terrible, but together it's kind of overwhelming. So, first one here, let's take them separate, right? 3 to the log base 3 is 7. What? I got exponents, logs in the exponent. Crazy. Well, we can actually evaluate this one. You're going to kind of notice just a little pattern, a little trick that you can remember. But I'm going to show you guys how it works, okay? If I want to just deal with this part right here. 3 raised to the log base 3 of 7. And I want to figure out what that equals. I'll set it equal to some number, say, x, okay? I'm currently in exponential form, even though there's a log. It's 3 to a power, that's just a number up there, equals x. So I could rewrite this in logarithmic form. I like to use a thing called loop and swoop, right? It helps me remember the order of things. So I've got log base 3 of x equals log base 3, my exponent right here, log base 3 of 7. Well, I've got log base 3 and log base 3, so shouldn't the arguments be the same if the bases are the same and there's nothing else going on here? Absolutely. So I know that this is just going to equal 7. So what a lot of people do is they think like, oh, I'm just going to kind of cancel that out. 3 to the log base 3, that's gone. It's just 7. This is the math behind it. I like to show that. It helps you remember some things. Cool? So moving forward, you see something like that, it's just 7. All right? So I've got 7, and then over here we have negative 5 times log base 10 of 100. Well, what is log base 10 of 100? It's 2, right? Because 10 to the second power is 100. So we'll do minus 5 times 2. This right here is equal to the 2. Boom. That's a terrible arrow. All right. And then the last one here, even more challenging yet, in my opinion. I think these are tough when you get fractions. We got to think of this as 4 to what power gives me 1 over 16? Well, 4 to what power would give me 16? 4 to the second power would give me 16. So 4 to the negative second power would give me 1 over 16. So this is going to be negative 2. I'll put it in parentheses. You don't have to. All right. But anyways, it's going to become subtraction, right? So let's clean some things up. I got 7 minus 10 minus 2. So that's negative 3 minus 2 is negative 5. There we go. First one down, right? Now, I would say this is more of like an honors level problem. But I think individually, I could ask you this question on a regular Algebra 2 test, or even 5 times log base 10 of 100 on a regular Algebra 2. A little challenging, but definitely doable, right? In their own pieces, definitely fair questions for a regular Algebra 2 class. Altogether, more of your honors level type thing if you can suss everything out, right? Okay, cool. Let's move to the next one over here up top. Top right. Natural log of e to the 8th. Ooh, what? I don't know what e to the 8th is, right? However, there's a property here with logs where I can move this 8 out as a coefficient. So I'd have 8 times natural log of e. Anybody know what natural log, what the base is of a natural log? Anybody? 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 It's e. So I have log base e of e. What's log base anything of itself? Log base 2 of 2. Log base 3 of 3. Log base 4 of 4. They're all 1. So this is really 8 times 1, which is just 8. Boom. We just 8. Left no crumbs. Next one over here. I got negative 1/2 times log base 3 of 81. Well, 3 to what power gives me 81? 3 to the 4th, right? 3 squared is 9. 3 to the 3rd is 27. 3 to the 4th is 81. If this is a non-calc type problem, which all these can be done without a calculator, they're going to be favorable numbers, guys, all right? So just start guessing through your integers, if you will. So I have minus 1/2 times 4. That's going to give me minus 2. So a minus 2 down here. I'm kind of working in a row here, right? So I can work with one thing. Because I feel like it's helpful to just kind of work your way down each one of these because some of them are multiple steps. All right, next one here. Oh, boy. Log base 5 of 25 to the 7th. Do you know 25 to the 7th? I know 25 times 7, but I don't know 25 to the 7th. That's a really big number. So how about this? Same idea. We just use that over here, right? So plus 7 times log base 5 of 25. So now what's log base 5 of 25? That's something that we can evaluate by hand. 5 to the second power is 25. So plus 7 times 2, which would be plus 14. Oh, boy. Now we're ready to work. 8 minus 2 is 6, plus 14 is 20. Next one down. Okay, we're still recording. Cool. I was worried that paused on me, man. We got some mathematical gold here, people. Mathematical gold. All right, next one. It's a lot of stuff, man. Maybe this is too much for one. No, it's never too much for one video. All right, let's keep going. So we got 6 times log base 8 of 1 plus e to the natural log of 4, weird, minus log base 1/2 of 8. Throwing them all at you guys, right? So again, all these could be done like in separate problems. Even on an honors test, we might just be like, what's log base 1/2 of 8, right? Multiple choice, free response, whatever, quick thing. Throwing them all together, more of a challenge problem. You might see one of these, maybe two on a test, all right? In my opinion, anyways. So over here, what's log base 8 of 1? Well, 8 to what power gives me 1? How can I get anything to equal 1 from a power? To the 0 power. So we got 6 times 0, which is 0. Nice. First one done. Next one, we have e to the natural log of 4. So e to the natural log of 4, right, could be written as e to the log base e of 4, right? Because natural log is just log base e. Doesn't this look familiar to this one right here? 3 to the log base 3, e to the log base e. Boom, it is just 4, kids. It's just 4. No big deal. All good. Next one over here. Maybe a little trickier. I don't know, right? 1/2 to what power gives me 8? It's going to be minus here, right? 1/2 to what power gives me 8? Well, how about this? 2 to what power gives me 8? 2 to the third gives me 8. So 2 to the negative, or sorry, 1/2 to the negative third would give me 8. Okay, let's do that. So we got negative 3 here. That becomes positive, so plus 3. I think we might need to work that one out, okay? And we got a little bit of room here, so I'll work it out right down here, okay? So I think seeing this one, let me get a more drastically different color. If we had log base 1/2 of 8 equals x, okay? Like if you have a tough time thinking about it, like I was just talking about, okay? I can loop and swoop this thing into exponential form, and I have 1/2 raised to the x power equals 8, okay? Hopefully you can see that right now. Let me look. We're good, okay? So 1/2 to the x equals 8. Well, I like to think of these when I have fractions here, is let's just do 2 to what power? A little sidebar here. 2 to what power? 2 to the x equals 8. What would that be? Well, then x would equal 3 here, right? X would equal 3. 2 to the third power equals 8. So if I do 1/2 to the third power, I get 1 over 8. So 1/2 to the negative third power would give me 8 over 1. It would flip it. So that's how we got ourselves negative 3, which then became positive because it was minus negative 3. So now we get our final answer. I got all sorts of markers going on here. Final answer is going to be 7. All right. There we go. These, honestly, they take a bit of practice. You get stuck on certain things, but as you practice through these, you start to notice some different patterns. Some little tricks that we throw in there are things that, like, you know, commonalities. You'll see e to the log base e to the natural log, right? Or you'll see the 3 to the log base 3, and some common ones like that. Or right over here, log of 10. We love throwing just log because everybody's like, huh? What's the base? It's 10. So right now I have log base 10 of 10 to the 7th. Let's just throw a little 10 right here. That looks, kind of familiar, maybe. But if not, it's okay. Let's pull the 7 out front here. 7 times log base 10 of 10. Haven't we had something where the bases were the same prior here? Maybe. I don't remember. Maybe not. I don't know. It's somewhere in there. But anywho, log base 10 of 10. 10 to what power gives me 10? It's 1. So if I have the base matches the argument, it's going to be 1, right? Kind of like how the base matched this base and it worked itself out. It's gone, poof, right? Same kind of idea. So here I'm going to have 7 times 1, which is just 7 for that one. Yay. Next one. We've seen this before, right, guys? We've seen this before. 5 to the log base 5, 3 to the log base 3, e to the log base e. It's just 6. So we're going to bring that all the way down here. It's going to be minus 6. And then next one here. Ooh, natural log and e. Interesting. And I have a 7. Oh, my goodness. Let's do this. Let's break this down, okay? I can bring my exponent, move it out front as a coefficient, right? Power rule there. So 7 times 3, so plus 21 natural log of e. I can even make this a cursive L for natural log, so it doesn't look like a 1 as well, right? Okay. And let's see here. Natural log, that's log base e, right? So this would be plus 21 log base e of e. Log base 10 of 10 was just 1. Would it make sense that log base e of e is also just 1? Absolutely. So this is 21 times 1, which is just plus 21. So then we got 7 minus 6 is 1, plus 21 is deuce, 22. Nice, man. That was a lot. If you guys stuck around for all those, impressive. These take a little while sometimes to just make sure you evaluate it all properly. Obviously, if you have your calculator, you can type this stuff all in, kind of be tedious. But these are generally going to be non-calc problems. And as I said, Algebra 2 honors, even some pre-calc honors, will throw some of these at you in full in their log units. Algebra 2 regular, more likely to get maybe like a piece of the puzzle, okay? They might give you the log of 10 to the 7th and see if you can evaluate it. I often see this one right here, as I mentioned a few times, or e to the natural log of 4. They'll throw those in pieces at you so not overwhelm. But in the honors world, I'm throwing 3. I'm throwing 3 at you. Maybe 2, 3. I don't know. We'll see what happens. Cool? Sound good? Awesome. Thanks for sticking around, you guys. Thanks for watching, and continue watching and logging those dope math hours. See you later.